Good evening, class. My name is Andrew Spilsbury, and I will be talking to you today about my paper titled Physics, Metaphysics, and the Evolution of Knowledge. The idea of my paper was um, first came to my mind when I thought about how in human history and up until the 20th century, a person who was said to have a well-rounded education would usually have a strong background in science as well as the liberal arts. However, as science became more and more specialized, theoretical knowledge became very complex, and as a result, it was difficult for even the most educated minds to keep up with the modern scientific discoveries. For philosophy in particular, this presented some interesting problems in the areas of epistemology and metaphysics. The literature that I was able to review on the subject indicates that there's either a lack of understanding or a lack of interest uh, as it pertains to relativistic and quantum theory and what they have to offer. From a humanist perspective, the idea that scientific discoveries should become esoteric is especially tragic. In the height of the Enlightenment, philosophers and writers counted on the scientific discoveries as a means of validating ideas consistent with reality and also dispelling mysticism, or the mysticism that had plunged the Western world into darkness. Throughout the ages, there are some questions that philosophy and science have competed to answer. Among these, we find those relating to truth and knowledge about time and space. These topics in themselves are instances of larger ideas of play or at play, namely in the way that we come about discovering truths in the natural world and how we should find reality. Aristotle was probably one of the first um, serious scientists to try to attempt to answer the question. The common sense philosopher, as he's known, used observation and reasoning as a means of obtaining knowledge. For hundreds of years, this worked out okay, but eventually it was insufficient and it led to stagnation in terms of discovery. For this reason, it's not strange that philosophers and writers like Francis Bacon and Michel de Montaigne criticized them for it. In his Apology of Raymond Sabon, Montaigne asks or questions whether the senses are sufficient in order to obtain any kind of knowledge, and he talks about how the mind is a feeble thing and can be forgetful and basically not useful when it comes to discovering things. Bacon, for his part, seems to answer the question in his Novum Organum when he talks about the idols of the tribe, and he realized that Aristotle's error was in thinking that he was the measure of all things. As a proposed solution, he offers that we use instrumentation and that we use measurement as a means of making up for the inherent errors that were found in reason and observation alone. So Bacon's model, in essence, uh, offers mathematics as a way of overcoming these issues with observation. I'm saying this because at the heart of using instrumentation and measurement is the idea of collecting data that establishes patterns and then can be useful to doing things. Now, as far as philosophy goes, the problem of obtaining knowledge in the natural world was really divided between two camps. It was the Cartesian rationalism and the continental empiricism. Um, on the rationalist side, Rene Descartes was concerned that no knowledge can be obtained through experience. He offered the thought experiment of the evil god that was deceiving him, and that he had to find a way to obtain knowledge. And he decided that the only way that he could do that was through thinking it out. It's one of his famous quotations is, "I think, therefore I am." He was establishing the idea that the mind itself could discover things. Now, this in itself worked out pretty well because thanks to Descartes, he was able to come up with the analytical geometry necessary to formulate the laws of reflection, refraction, and so a pre-Newtonian version of mechanical momentum. Now, on the empiricist side, David Hume, in his essay concerning human understanding, questions how anybody is to know anything without experiencing it first. How do you know that water will not drown you if you don't come into contact with it first? How will you know that fire will not burn you if you don't come in contact with heat? So, with that is the question of how you can know anything without experience, but also how you can know anything about the future um, based on those experiences. He said that a man could live 100 years and see 100,000 sunrises, but he would never know for sure that the sunrise was going to fall the next day. Excuse me. So in current terms, we know that the sun is going to come out the next day because we have NASA that tracks astronomical phenomena that occur daily. It follows the Earth and its geodesic around the sun. And so we have we're able to operate in terms of confidence intervals and percentages of probability. But David Hume, regardless, was able to provide some interesting feedback in the way that that we understand what the limitations are for experiential knowledge. Now, of the great philosophers, Immanuel Kant was probably the first to reconciliate the two uh, diverging ideas of experience and reason. In his critique of pure reason, he proposes that there are two main types of knowledge, one which is experiential and the other one which is the reason alone. He called this a priori and a posteriori. Now, using Kant's language in his critique is especially important because it explains the role of mathematics as it pertains to achieving objective truth, particularly in the evolution of physics. In Kantian terms, mathematics fell into the realm of a priori, um, uh, but experiential knowledge was required in order to be able to make sense of those mathematical structures and techniques, etc., etc. Uh, we at some point or another we've all taken algebra, and so the example that I like to use for this is that if a ball is shot out of a cannon, it forms a parabola. Now, if we're trying to figure out where where the ball is going to land, it will be necessary for us to use the quadratic equation that is associated with that parabola. If you remember, how that goes along, you will actually get two solutions, one of which you will have to discard. Now, that doesn't mean that the solution that you're discarding is not true. It's mathematically true. It just means that it doesn't pertain to reality. And so that's where you get the feedback from experience as it pertains to what has been reasoned out before through math. Now, in the world of physics and natural philosophy, there is no one that can be said to have used this kind of synthetic method more than Isaac Newton. Isaac Newton was able to use math and empirical evidence before in order to come up with objective truths. Now, Newton's contribution to the realm of knowledge in the physical sciences can be qualitatively understood in two areas. The first is that Newton's method can pass the most rigorous philosophical and mathematical analysis. The second was that Newton, in a way, answered Hume's question because he was able to predict future events based on observation and calculation. The sun would rise the next day because the earth had inertia as it spun around its axis, etc., etc. In the 19th century, however, there was a crisis of knowledge because Newtonian law was put to the test. It was discovered that light didn't follow the same rules as everything else. Also, in the sense that it would not follow vector addition or subtraction. You couldn't make light go any faster, or you couldn't slow it down. Additional observations in newly acquired field of quantum physics provided other examples of uncertainty. James Maxwell Clerk found that the kinetic velocities of particles within a gas could only be described in terms of statistical probability. These experimental discoveries created a crisis in knowledge and doubt that mathematics alone could help answer the universe's biggest mysteries. Now, in the later part of my paper, I introduced Einstein and his solution to the crisis of knowledge. I propose that he solved the crisis of knowledge by reimagining metaphysics and the value of making conjectures. As described by a philosopher of the time, Henry Bergson, he utilized intuition and imagination as a means of attaining first principles. Albert Einstein liked to pose thought experiments that suggested the speed of light could not be added upon because it was just the nature of the physical world to impose a limitation on it. Einstein also understood that experimental science would not soon yield the reason for the universal speed limit. Instead, he accepted it as a truth, as an axiom, and tried to see what other truths it could reveal from it. The result was a discovery that under the very special conditions, time, matter, and space did not follow classical theory. Einstein was not able to work in a bubble. He still had to confirm his conjectures using mathematics, and at that point was that non-Euclidean geometry was developed, or was being developed at the time, and he was able to take advantage of that in order to validate his theories. As far as experiments go, it wasn't until 1925 that he was actually able to prove that his theories were valid, and that was thanks to the astronomer Hubble, that he was able to observe that light actually bends around the planets. In any case, I conclude my comments or that section of my essay by saying that that Einstein essentially mended a schism that had been created between philosophy and physics. He was able to utilize an empirical approach by taking into account the newest information, i.e. the knowledge that light didn't follow Newtonian law, and married that with a theoretical construct. He goes on to say, or Einstein goes on to offer a specialized version of the Kantian synthesis of rationalism and empiricism. And that's how basically I conclude this paper. If you have any feedback, I would be greatly interested in it, as I always like to improve my writing and my ideas. I hope you enjoyed this video, and I look forward to hearing from you. Thank you.